All right, guys, let's look at another one. This one, the graph's not given to us. This time we actually get to draw the graph. All right, so here we go. The path from my front door to my car is a straight line, a distance of 10 meters. Towards my car, we'll consider as positive displacement. Away from the car is negative displacement. All right? One day, my family decided to make a trip to the beach. Walk out to the car, you can read the directions from there. At the bottom here, this is the information we need to draw a graph. Use the graph below to draw a graph of any motions as we try to leave to the beach. X-axis can be in sets of 5 seconds. All right, so let's go 5, 10, 15, 20, 30, 40, 50, all right, 60, 70, 80, 90, 100, 110, 120. All right, so that's in seconds. Okay, and then the y-axis is in terms of meters. So we're back to position versus time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this right here is our 0, 0 mark, 0 time, 0 position. This is in meters, right? So it is position versus time. So let's see what we can draw. Okay, first thing we're going to do is try to draw the graph of what we see. All right, that is what it says. It says, use the graph to draw a graph of my motions as we try to leave for the beach. So let's read. We walk out to the car. This takes about 10 seconds. All right, so we start at the beginning, and it takes us 10 seconds to get out to the car, which is 10 meters away. So we'll assume it's more or less constant. So 10 seconds to walk out to the car. All right, and I wait for 20 seconds as my kids pile in the car. So from 10 up to 30, I'm stationary. I'm by the car waiting for my kids to get in. It's at this point that one of my daughters realized she has to go to the bathroom now. It takes us 5 seconds to get her out of the car and back to the house. So from 30 to 35, we're gonna rush back all the way down, okay? It takes, where I wait for 30 seconds as she goes to the bathroom. So 35, 10, 20, 30 seconds. All right, I'm at 65 now. So now she's gone to the bathroom. Got that done. We then walk slowly back to the car because her swimming suit fits weird now. It takes me 10 seconds to get halfway there. So 10 seconds, so from 65 to 75, and I need to get halfway there. The distance was 10, so halfway there would be 5. So we're walking back, and I realize we forgot the sunscreen. So I immediately return back. It takes me 5 seconds to return. So I'm at 75, so by 80, I'm gonna return to the house and grab the sunscreen right by the door and walk at my normal pace to the car. So another 10 seconds to get to the car. There we go, get to the car. All right, I sit down in the car and search for my keys for 10 seconds, and I cannot find them, and so I walk towards the house. It takes me 5 seconds to walk 8 meters. So 1, 2, 3, 4, 5, 6, 7, 8. 5 seconds, so there we go, 5 seconds to walk 8 meters, at which point my wife calls and says she has them in her purse. 5 seconds more, back to the car, and I sit and breathe until I'm mentally prepared to drive. The whole process takes 2 minutes, and so that's where I'm gonna stop right there. There you go, so that's what my graph is gonna look like, right? We did that all by looking at the times, the positions, and building this position versus time graph. So when do I travel the fastest? When is the slope the steepest? Well, hopefully it's when we're rushing to get back to the bathroom, right? We get from 10 to 0 in 5 seconds. So that's, but from time is 30 up to 35, between 30 and 35 seconds. That's when I travel the fastest, right? That's the steepest slope. You can double check all the other slopes. This one over here is close, but that's only 8 meters in 5 seconds. The fastest is definitely when we run back to the house. During what times do I have negative velocity? All right, well, negative velocity is anytime I have a negative slope because this is position versus time. So from 30 to 35, from 75 to 80, from 100 to 105, and that's it. Those are the 3 segments where I have negative velocity. Anytime I'm walking back towards the house, that's negative velocity. Name at least one point when the object accelerates. That means that it changes velocity. Now, that could be really any of a number of situations, right? Anytime where my slope changes, any of these are appropriate places where I'm accelerating, okay? It doesn't have to be speeding up. Slowing down is, and changing direction is. All of those are acceleration, all right? So any of those points answer number 3 for us. How long do I have to rest at the end? Well, it looks like I end up having 10 seconds there at the end to take a break, all right? What is the total distance I've traveled during the 2 minutes? Okay, well, let's add it up. Let's figure out how far did I travel. Well, I traveled 10 meters here and then 10 meters back to the house, so that's 20. And then I go 5 and 5 again, so that's 20, 25, 30. Then I go 10 back to the car, so that's 40, 10, 20, 25, 30, 40. And then I go 8 and then 8, so that's going to be 40 plus 8 plus 8, which is 16. And so my final answer is going to be 56 meters. I travel 56 meters in the time that I'm trying to get from the house to my car. All right? Believe it or not, it happens. What is my total displacement? Well, I start at 0 and I end at 10. So my total displacement is only 10 meters. Even though I traveled 56 meters and I'm probably exhausted from running back and forth, my total displacement is a minimal 10 meters. My average speed, remember, is distance over time. So average speed, I'm just going to take that 56 meters and divide it by 120 seconds. And so if I do 56 divided by 120, then I'm going to go ahead and put my answer in 2 sig figs. I'm going to go 0.47 meters per second. All right, now that may not seem very fast, but it's because I do have a significant amount of wait time, right? There's a lot of time where I'm sitting around not doing anything, right? When I'm waiting for my kids to get buckled in, when I'm waiting for my daughter to go to the bathroom, right? All of these waiting times are 0 velocity, and so 0 speed, and that is going to decrease the total average speed of the trip. All right, so that's it. We got all the answers. We answered all 7 questions, and we drew the graph. I hope that was helpful, and go ahead and watch the last one if you want.